Okay, in part A, we want to write an equation that defines the exponential function with a base a being greater than 0. So that means we would write a exponential function, f of x, which is going to equal a base of a, so that means it would have to have an exponent of x, where the value of the base a is greater than 0. Now for part B, it says, what is the domain of this function? Meaning, what are all the x values that we can plug into that function? Well, that means that x, such that x can be any real number. Or in interval notation, it would go from negative infinity to positive infinity. Okay, now if the base a does not equal 1, then what is the range of this function? Well, the range of an exponential function always goes from the value of 0, but not including 0, to positive infinity. Okay, now in part D it says we want to sketch the general shape of the graph of the exponential function for each of the following cases. So the first case is where a is greater than 1. So, meaning the base is greater than 1. So let's take a look at graphing a function. So if we let that base be, let's say, 3, and that's greater than 1, okay, and then our exponent has to be x, then we can see what this shape looks like. So let's go ahead and copy this graph. And so that's where so this is where our graph is f of x, which is equal to 3 to the x, which represents our first scenario. Okay, now we want to see when the base is equal to 1. So let's go ahead and do that. So whenever we have 1 to the exponent of x, then we get a horizontal line. So therefore, it's going through the value of 0, 1, but it is a horizontal line. So now we can see what the graph looks like when, and again, this is scenario here, where f of x is equal to 1 to the x. And then let's take a look at the last one, where the base is going to be in between 0 and 1. So let's see what that looks like. So when it's in between 0 and 1, we can say 1/2. So we can write 1/2, and then we can raise that to the x power. So therefore, now we can see what this graph looks like. So this is the third case where we have f of x, which is equal to the base of 1/2 to the x power. So we can see that the first case is an increasing function going from left to right at a y-intercept of 0, 1. The second case, where the base is 1, we just get a horizontal line at passing through the point 0, 1. And then whenever the value of a is in between 0 and 1, we can see that this is a decreasing function. But again, it's going through the y-intercept of 0, 1.